Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. We will wait for 2 minutes. Let the participants join. And then we will start with the lecture. So almost 70 students are now in meeting. So we can start. Okay, just tell me whether the screen is visible. Yes, you are able to view the PPTs. Okay.
Yes, ma'am.
Yeah, thank you. So in the previous lecture, we have started with the chapter number 5, which was visible lines and visible surfaces. So in that, we have started with what is visible line and what are visible surfaces. Similarly, the visible surfaces can be also termed as the surfaces which we can view with respect to the viewer, obviously. So with respect to the viewer, the surfaces which are seen, those surfaces are counted as visible surfaces. And we are giving the name for this process as visible surface detection, VSD, right? We have seen this thing that visible surfaces are, we are finding them out with visible surface detection methods, or they are also called as hidden surface removal. So one and the same thing, we are finding out the visible surfaces or we are removing the hidden surfaces. Both things are same. We have seen the use of this visible surface detection is to make the picture more clear. That is one thing, that display becomes more clear once we remove the hidden surfaces. We have seen this example of drawing the cube. In that we have seen the surfaces which we can view. If we are able to display them, then the picture is more realistic and we are able to locate the front sides of this object. So that is one thing, that is there is no confusion which object is at the front and which object is at back. So accordingly, we can classify the front objects and back objects if the objects are overlapping. So that is the first application of this visible surface detection. And the second application is in terms of memory required to store these objects. So when I want to draw such objects on the screen, they should be fetched into the frame buffer, right? So the information about this object is stored in the hard disk, that is the main memory, and I want to display it onto the screen. So they are brought into the frame buffer. So if I know which surfaces need to be displayed only, because this object, a cube, is having total 6 surfaces. Out of 6 surfaces, only these 3 surfaces are visible. So unnecessarily fetching the information about the total 6 surface, what I can do is I can fetch the information which is needed, that is the information about 3 surfaces only, which are visible with respect to the user. So I can brought the information about these 3 surfaces and then I will display it onto the screen. So unnecessarily fetching the information of the back faces or hidden surfaces, it will create the higher memory requirement, or it requires higher memory requirement. So instead of that, the memory requirement will be less if we are removing the hidden surfaces from our objects. Okay. Yes, is there any difficulty? Okay, so 2 advantages we have seen, that is the picture is more clear, the complex picture become clear to represent it on screen. And second thing is it minimizes the memory requirement for displaying such images. So these are the two advantages or applications with respect to visible surface detection or hidden surface removal. Okay, so we have seen this is done in two ways. This is done in two ways. First is actually the surfaces are getting removed. First is actually the surfaces are getting removed. That means out of these 6, we are fetching only 3 surfaces. That means the remaining 3 surfaces are totally discarded. So this is the one approach in which we are actually identifying the visible surfaces and eliminating the hidden surfaces. We are actually removing those hidden surfaces. And the second method is, instead of removing the surfaces totally, we are drawing the dotted lines instead of the solid lines. The surfaces which are at the back, for them we are drawing the dotted lines instead of hidden line, instead of solid line. So here you can see the surface which is at the back, the surface which is at the back, the surface which is at the bottom, and the surface which is on this side. These 3 surfaces are hidden. So to represent them, the dotted line is drawn. So here you can see how to display the backside portions, or backside, what we can say, backside faces. So those surfaces can be represented with the help of dotted lines. Why these dashed lines or dotted boundaries are required? To imagine or to retain the shape of the object. So if we are using here the dashed lines, then we are easily recognize that this is the diagram of a cube. So we are having the, we are retaining actually the shape of the object by using the dotted lines. So these two approaches are done while detecting the visible surfaces. So visible surface detection or hidden surface removal is having total 2 things to consider. First is total removal of the surfaces, and the second thing is, instead of solid lines, we are using the dotted lines to represent the actual shape of the object. Okay, so if we are using the dotted lines, both the purposes are achieved. Both the purposes are achieved. That is, we are removing actually, we are separating the visible and invisible surfaces. That is one thing we need to one thing we are requiring. And the second thing is, we are knowing the actual shape also. So we are retaining the shape and we are separating the visible and hidden surfaces. So both the things are achieved by using this method or this approach. Okay, so this part we have covered in the previous lecture, and now we are going to see the two fundamental approaches that we have studied, where the object space method, where actual physical coordinates are considered. So here the physical coordinates are considered like actual XYZ values. And the second approach to do the hidden surface detection or removal is called as image space, in which the screen coordinate system is considered. So here it has something to do with the representation on the screen. And in the object space, the actual physical coordinate system is considered to remove the hidden surfaces. So these are the two approaches how we can start detecting the hidden surfaces. Out of that, the first method that we are going to learn is backface removal algorithm, which is totally based on this first approach, object space method. So the first method is backface removal algorithm. The name itself gives you idea that backside faces it is going to remove, and this method uses the object space or physical coordinate system approach, in which we are going to learn, or we are going to consider the characteristics of actual object, to recognize the hidden surfaces. So that is first method. In the second method, the Penter's algorithm, or it is also called as a depth sort algorithm. In that algorithm, it is a combination of both the methods. It uses the object space as well as it uses the image space as well. So both the methods are used in Penter's algorithm, or it is also called as depth sort algorithm. And the remaining two algorithms that we are going to learn are Z-buffer algorithm and area subdivision method algorithm. So in that area subdivision and Z-buffer, we are using the image space, that is screen coordinate system. Okay, so this much part we have seen in the previous lecture, and now we are going to start with the backface detection. So we have seen a simple test in the previous lecture. What is the meaning of backface? So backface, in that, the very basic thing is it is using the inside and outside test. So it uses the inside outside test, and it is the object space method that we have already discussed. And it uses the formula or the expression for the faces of polyhedron.
हॅलो मॅम,
Yes.
आवाज ब्रेक होतोय मॅम तुमचा मधून.
Okay, actually from morning itself I am facing the network issues here. That's why I took longer time for starting the lecture as well. Okay, is it clear now? Or still it is breaking?
No, ma'am, still it's breaking.
Okay, let me rejoin again then. Okay, so we will try by making my video off. Let us see whether it will give you the clear voice or not. Okay, now tell me whether the voice is better than the previous one. Okay, right. So we will start with by making the video off, as the bandwidth is not good today. So we will make the video off and we will start with the lecture again. Okay. Now just confirm whether the screen is visible. Yes, screen is visible.
Yes ma'am.
Okay, right. So let us start with the backface detection algorithm. In this algorithm, I just now told you that it is the object space based method. which is the first approach of detecting the backside faces. So this algorithm is very fast and simple because it uses only one property of the polyhedron, that it uses the point whether it uses or it detects any point whether it is lying inside the object or outside the object, and that's why it is carrying out the inside outside test. So in this algorithm, see here, I will draw one diagram in which this is your object. Okay, so consider it is a cube and the camera is over here. Or the user is over here. The direction of view is this. Okay, so the user is viewing from this direction. Now, in this algorithm, it is considered first part is it is checking any random point x comma y comma z, because if I am checking any point in the 3D object, it has 3 coordinates x, y, z. So with this x, y, z, suppose this is a point. Suppose this is a point that I am checking, or instead of this we can say, okay, let it be. So for this particular point P, I will check whether this point is inside or outside the polyhedron. So this P
Hello, ma'am.
has, yes. Yes, students.
Ma'am, diagram is not visible.
Diagram is not visible.
Yes, ma'am, now visible.
Okay, maybe lag is there somewhat, but okay. So on this object, I am drawing here the camera. The viewing direction is this, and I am going to check whether the point P. 1 second, students, hold for a minute. Yes. So sorry for the disturbance. Actually, the important call was there. Okay. So am I audible now? Yes, students. Okay. Thank you. So we have seen that backface removal algorithm or backface detection uses the object space in which the actual characteristics of objects are considered. So this is your 3D object. So it has characteristic that every point is denoted with its x, y, and z coordinate. So in object space, the actual coordinates are considered, and the actual characteristics of the object are considered to check whether the points are lying inside or outside. So this is very important thing, that it checks whether the polyhedron, in that particular polyhedron, whether the point lies inside or outside. That is the first thing. So it carries out this test, inside outside test, for this point P. Now consider this point P having x, y, z coordinate. So here it has the expression for the polyhedron that the plane parameters, here are the plane parameters A, B, C, D. So these are the plane parameters, or we are going to call them as coefficients of x, y, z. We are calling them as coefficients of x, y, z. So the point is inside when we are having the formula. We are having the particular formula for that point as the coefficient of x, that is ax, plus by plus cz plus d. If this expression is greater than 0, if this expression is greater than 0, then we will consider that the point is inside. If this condition is satisfied for x, y, z coordinate with fixed coefficient a, b, c, d, and when I put x, y, z in this formula and the value is greater than 0, then that point lies inside the polyhedron. So we are having this particular expression. Now once this point is considered as inside point, then we are going to draw normal with respect to the surface. Now this is the surface on which this point P is present. So first thing आपण काय केलेली आहे, तो पॉइंट इनसाइड आहे की आउटसाइड, म्हणजे इनसाइड आहे का आउटसाइड ऑफ दॅट ऑब्जेक्ट आहे हे आपण चेक केलेलं आहे. दॅट इज युअर फर्स्ट पॉइंट एक्स, वाय, झेड. Then second is, with that point P, we are going to draw a normal. We are going to draw a normal that is the perpendicular to the surface. आता हा point P आहे या surface वरती. So I am going to draw a normal on this surface. So the direction of normal is this. The direction of normal is this direction. Okay. So similarly, if the back face is considered, आता मी dotted line ने तुम्हाला back face दाखवतीये. जसं या पॉइंट पासून ही नॉर्मल आहे, विच इज पॉइंटिंग टुवर्ड्स राईट हँड साइड विथ रिस्पेक्ट टू दिस कॅमेरा. आता ही राईट हँड साइडला डायरेक्ट करते. तसंच जर हा बॅक साइडचा पिक्सेल असेल एक क्यू, दिस इज द बॅक साइड पिक्सेल, आणि या सरफेस वरती मला जर नॉर्मल ड्रॉ करायची असेल तर ती काय होईल, ती नॉर्मल अशी ड्रॉ होईल. ओके. सो consider this is the back side and I am drawing the normal which is pointing away 90 degree. या सरफेसला 90 डिग्री ड्रॉ करतेय मी ही एक नॉर्मल n. आता जेव्हा मी ही नॉर्मल बघतीये तेव्हा काय होतंय, दिस इज द व्ह्यूइंग डायरेक्शन, सो आय विल कॉल इट ॲज v, and this is the normal which I will call it as n. So when the viewing direction and normal, they are in the same line, आता तुम्ही बघताय की हे व्ह्यूइंग डायरेक्शन आणि नॉर्मलची डायरेक्शन सेम आहे. दे आर पॉइंटिंग अवे फ्रॉम द युजर. दे आर पॉइंटिंग अवे फ्रॉम द युजर. सो याची डायरेक्शन दोन्हीची सेम आहे. दॅट मीन्स दे आर ओव्हरलॅपिंग. आय कॅन शो इन द सेम मॅनर. ही तुमची व्ह्यूइंग डायरेक्शन आहे आणि तीच तुमची नॉर्मल पण आहे. That means what is the angle between these two? What is the angle between these two? 0 degree. जर एकाच लाईनवर दोन्ही येत आहेत याचा अर्थ काय होतो की V आणि N हे एकाच लाईनवरती एक्सटेंड होत आहेत. दॅट मीन्स द अँगल बिटवीन देम इज 0 डिग्री. दे आर ऑन द सेम path. So when V and N has same direction, the normal that we have drawn from the point of the surface, then when they are of the same direction, then we are going to call the face for this normal is backside face or back face. जेव्हा व्ह्यूइंग डायरेक्शन आणि नॉर्मलची डायरेक्शन ही सेम पाथ वर असते, that means the angle between them is 0 degree, then we are going to call that face as back face. कळतं इथपर्यंत? Yes, students. Yes, students, whether you are getting?
मॅम एकदा रिपीट करा.
ओके. फर्स्ट बॅकफेस रिमूव्हल मध्ये काय येतंय, याच्यात 3 स्टेप्स आहेत टोटल. त्या 3 स्टेप मधली पहिली स्टेप आहे की एक पॉइंट, कुठलाही सरफेसवरचा एक पॉइंट घ्यायचा P, ज्याचे कोऑर्डिनेट्स XYZ असतील. कारण हे तुमचं 3D ऑब्जेक्ट आहे बरोबर. त्याशिवाय तुमचं बॅकफेस येणारच नाही. कारण जर प्लेन मध्ये एक XY प्लेन मध्ये जर तुम्ही प्लॉट करत असाल एक 2 डायमेन्शनल ऑब्जेक्ट, फक्त एक पेपर, तर ते तुम्हाला सगळे त्याचे साइड्स, सगळे त्याचे फेसेस विजिबलच असणार आहेत त्या केसमध्ये. जेव्हा 3D ऑब्जेक्ट असेल तेव्हाच त्याचे काही फेसेस पाठीमागे असतील आणि काही फ्रंटला असतील विथ रिस्पेक्ट टू द व्ह्युअर. बरोबर. सो इट इज युअर 3D ऑब्जेक्ट. नाव त्या 3D ऑब्जेक्टचा एक एक्सप्रेशन आहे ax प्लस by प्लस cz प्लस d ग्रेटर दॅन 0. हे कुठल्याही पॉलिहायड्रॉन साठीचं एक्सप्रेशन आहे की इट इज सॅटिस्फाईड बाय ऑल द पॉइंट्स ऑफ द पॉलिहायड्रॉन. कुठल्याही पॉइंटचा XYZ व्हॅल्यू मी पुट केली तर मला कळतं की तो पॉइंट त्या पॉलिहायड्रॉन मध्ये आहे की नाहीये. सो फर्स्ट मी काय करणार आहे, कारण मला त्या पॉइंट पासून नॉर्मल काढायची आहे. जर तो पॉइंट नसेलच सरफेस वरती, कुठलाही एक रॅन्डम पॉइंट असेल, हा पॉइंट आहे, तर त्याची नॉर्मल मला काढता येईल का? नाही, कारण मला सरफेस विथ रिस्पेक्ट टू सरफेस त्याची नॉर्मल ड्रॉ करायची आहे. सो फर्स्ट आय हॅव टू चेक द पॉइंट इज लाईंग ऑन द सरफेस ऑर नॉट. मग तो जर पॉइंट या सरफेसवर असेल तरच मी नॉर्मल काढू शकते. सो पहिली टेस्ट काय, एक कुठलाही पॉइंट घ्या P. आता या सरफेसचं मी चेक करतेय फॉर किंवा बॅकग्राऊंडचं घ्या. पाठीमागच्या सरफेससाठी मी चेक करतेय विच इज लाईंग ऍट द बॅक. इथे कॅमेरा आहे म्हणजे युजर इथून बघतोय. स्टिल इट इज ब्रेकिंग.
येस मॅम, कळत नाहीये काहीच.
ओके, लेट मी रिजॉइन अगेन. लेट मी रिजॉइन. Just check whether am I audible now, whether the voice is clear.
Yes, ma'am, audible.
Okay. Okay. Now see, in the backface removal, we have already discussed that it is the object space method in which the actual characteristics are considered. Actual characteristic म्हणजे त्यांचे physical coordinates x, y, z. So here I am drawing the diagram of a cube and I am going to check with the actual coordinates of this object. I am going to draw the actual coordinates. Okay. Right now, this is your back face. Your camera is here. So from this camera, I am looking at the object. Now, if I am looking from this particular camera, then the faces which are visible are 1, 2, and 3, for example. 1, 2, and these 3 faces will be observed, while the remaining surfaces are on the back side. जर मी back side चा हा एक point घेतला, which is at the back. Okay. Now consider this is point P. मग फर्स्ट मी काय करणार आहे, इन बॅकफेस डिटेक्शन मध्ये मी इनसाइड आउटसाइड टेस्ट कॅरी आउट करणार आहे. सो आय एम गोइंग टू कॅरी आउट द इनसाइड आउटसाइड टेस्ट टू आयडेंटिफाय वेदर द पॉइंट इज लाइंग विदिन द पॉलीहायड्रॉन ऑर नॉट. कारण काय करायचंय, मला पहिल्यांदा पॉइंट चेक करायचा आहे पी, वेदर इट इज इन ऑर आउट. फर्स्ट पॉइंट काय आहे, फर्स्ट स्टेप, आय विल चेक वेदर द पॉइंट इज लाइंग इन ऑर आउट. Because from that point P, I have to draw a normal. That is my second step. So XYZ is my first point P. And from that P, if it is lying inside, then I will draw a normal from point P with respect to surface. And then I will check whether that normal is pointing away, pointing towards, what is the angle between V and N, that I will check to give the result whether the surface is visible or back face. Okay. मग मी पहिल्यांदा काय करतेय, पॉइंट एक P घेतलेला आहे, त्या पॉइंट XYZ त्याचे कोऑर्डिनेट्स आहेत. So I will use the expression of the polyhedron. And what is that expression? I am having the expression AX plus BY plus CZ plus D. AX plus BY plus CZ plus D should be greater than 0. If this criteria is satisfied, it means the point is lying inside. जर ही व्हॅल्यू ग्रेटर दॅन 0 आली तरच हा पॉइंट इनसाइड असतो, otherwise that point is outside. ओके. मग मी पहिली केस चेक केलेली आहे. आता मला कळलंय की हा पॉइंट P आहे, तो इनसाइड दिस पॉलीहायड्रॉन आहे. मग आता या पॉइंट P वरून जर मी नॉर्मल काढली, माझा सेकंड पॉइंट काय, सेकंड स्टेप, की आय हॅव टू ड्रॉ अ नॉर्मल फ्रॉम पॉइंट P विच इज ऍक्च्युअली नॉर्मल टू द सरफेस. म्हणजे P जिथे आहे, P ज्या सरफेसवर आहे त्या सरफेसला मला नॉर्मल ड्रॉ करायची आहे. ओके. सो आय एम गोइंग टू ड्रॉ द नॉर्मल टू दिस सरफेस. हा बॅक साइडचा सरफेस आहे ज्याच्यावर पॉइंट P आहे. पहिल्या टेस्ट मध्ये मला कळलं की पॉइंट P हा इनसाइड आहे. सो आय विल फॉलो द सेकंड स्टेप नाव. सेकंड स्टेप मध्ये मी नॉर्मल ड्रॉ करणार आहे. नॉर्मल म्हणजे काय, तर 90 डिग्री लाईन त्या सरफेसवरची. आता हा तुमचा सरफेस आहे बॅक साइडचा. सो आय एम गोइंग टू ड्रॉ अ 90 डिग्री लाईन फ्रॉम इट. म्हणजे ती परपेंडिक्युलर असणार आहे. मी मुद्दामून डॉटेड आणि ही लाईन दाखवतीये, सॉलिड लाईन. इनसाइडची ही डॉटेड दाखवली आहे कारण तो पॉइंट बॅक साइडला आहे म्हणून. सो आय एम ड्रॉइंग दिस डॉटेड लाईन फॉलोड बाय अ सॉलिड लाईन. ओके. मग आता ही एक नॉर्मल लाईन मिळाली मला. सो मी काय केलेलं आहे, पॉइंट P जो इनसाइड आहे त्याच्यावरून सरफेसला नॉर्मल एक एन काढलेला आहे. एन इज हॅव्हिंग दिस डायरेक्शन विच इज पॉइंटिंग अवे फ्रॉम द युजर. ओके, ही झाली माझी सेकंड स्टेप. आता थर्ड स्टेप मध्ये मला काय करायचंय? थर्ड स्टेप मध्ये मला दोन्हीच्या डायरेक्शन चेक करायच्यात. दोन्हीच्या म्हणजे कशाच्या? एक व्ह्यूइंग डायरेक्शन विच इज कॉल्ड ॲज व्ही. ही माझी व्ह्यूइंग डायरेक्शन आहे. कॅमेराचा व्ह्यू मला असा मिळतोय. सो आय विल चेक द डायरेक्शन ऑफ टू थिंग्स. एक, द डायरेक्शन ऑफ व्ही अँड द डायरेक्शन ऑफ एन. इथपर्यंत कळतंय? आता सगळ्यांना कळालं इथपर्यंत? येस स्टुडंट्स? Yes, tell me. Is there any difficulty up to this point? Yes, reply fast. कळतंय का इथपर्यंत सगळ्यांना? कळालंय का? Girls? Yes, tell me fast so that I can proceed or I can repeat.
Hello, ma'am.
Yes.
Ma'am, your voice was breaking.
अजून पण ब्रेकच होतोय?
Ma'am,
Yes,
मगाशी
ma'am.
सांगताना पण ब्रेक होत होता.
ओके.
Not clearly audible, ma'am.
आता तरी येतोय का आवाज? का आता पण ब्रेक होतोय?
Break होतोय ma'am.
होतं मॅम.
ऍक्च्युली नेटवर्क इश्यू मुळे आज सकाळपासूनच असंच होतंय. Actually, I tried logging off and logging on 2 times, but still it is showing that unstable connection and all. Just check now whether the voice is clear. Yes, students, voice is clear now or it is still breaking? Actually, the network issue is there. So we will do one thing. We will stop for today. I will arrange the extra lecture tomorrow because tomorrow I will be visiting college. So I will arrange the extra lecture. Okay. And we will see this topic tomorrow again. Okay. So I will stop sharing the screen. We will stop here. I will convey you tomorrow's timing for extra lecture. Tomorrow you have your DMS lecture. Yes, students. Whether you have DMS lecture tomorrow?
Yes, ma'am.
Okay. At what time?
Hello, ma'am.
Yes.
Ma'am, at 12:15 there is environmental science lecture.
ES lecture 12:15 like
हा.
ठीक आहे मग 12:15 to 2:15 I will take. त्यांचं 2 तास असतं का?
Yes, ma'am.
ES चा ठीक आहे. मग मी उद्या 12:15 to 2:15 घेईन. मी त्यांना कन्वे करते तसा मेसेज. I will inform you accordingly. I will provide you the link and the timing, exact timing. उद्या घेऊ आपण extra lecture. Okay. So today we will stop here. Thank you.